can you solve this math challenge? Here's the question. If 2 raised to x plus 3 raised to y equals 4 raised to the power of z, then what is the possible triple x, y, and z, wherein x, y, and z are all integers? You can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so our goal here is to solve for the possible triple x, y, z that satisfies this equation 2 raised to x plus 3 raised to y equals to 4 raised to the power of z. Now, here's one of our observation in this question. The right-hand side of our equation 4 raised to z is always an even number when z is greater than 0. Alright. And 2x plus 3y, if the right-hand side is even, therefore the left-hand side must be also even. So must be even. Now take note that 3 raised to the power of y must be always odd, whatever the integer value of y, of course, from 0 up to positive infinity, and 2 raised to x must be always even, except for x must be equal to 0. So by observation, this x must be 0 to make this number 2 raised to x be equal to 1, that is odd. So odd plus odd will become even. Therefore, by observation, one possible scenario or one possible answer to this question must be when x equals to 0, for this 2 raised to x be an odd number, 3 raised to 1, y equals to 1, and z must be equal to 1. So we have 1 plus 3, and 1 plus 3 must be equal to 4. So one possible triples must be equal to 0, 1, and 1. Now, our claim is this is the only possible triple that satisfies this equation. But the other question is, how do we prove that this is the only possible triple that satisfies this equation? Alright, so to prove this, what we're going to do is to fix this x. So we need to fix this x as 0. The reason is to make this number 2 raised to x an odd number, x must be 0. There's no other value of x that makes 2 raised to x an odd number. Alright, let's simplify. 2 raised to 0 must be equal to 1. Now we need to prove that there's no other solution when z or y must be greater than or equal to 2. Alright. So, what we're going to do is to subtract 1 on both sides. And then this 4, we know this 4 is 2 raised to the power of 2. And 2 squared raised to the power of z can be written as 2 raised to z raised to the power of 2. Now, we have a square number minus another square number, so we can factor this using the difference of 2 squared. So, we can factor this as 2 raised to z plus 1 multiplied by 2 raised to z minus 1. Now, from here, we can now show that the factors in the right-hand side cannot be written in the form 3 raised to some integer power. The reason is to make the first factor be a multiple of 3, this z must be an odd number. So 2 raised to 1 plus 1 must be 3, so a multiple of 3. 2 raised to 3 must be 8 plus 1. 9 is a multiple of 3 also. And as you can see, when z is odd, 2z plus 1 must be a multiple of 3. Now, how about 2z minus 1? This factor is a multiple of 3 when z is an even number. So now, when z is greater than or equal to 2, there's no number z that is both odd and even. Therefore, 2z plus 1 and 2z minus 1 cannot be both a multiple of 3, or in short, the right-hand side cannot be written in the form 3 raised to some integer power. So we can say that there's no other solution when y and z are both greater than 2. Therefore, our answer to this question, the only values of x, y, and z that satisfies this equation is when x is 0, y is 1, and z equals 1. And as always, we are done.